Hello and welcome. Today we are going to cover a topic unlocking business value with RAG and MCP, and all of this through Pimcore and artificial intelligence. A little bit about me. My name is Marko Čučković. I'm backend team lead at Factory.dev. I have 13 years of experience and the usual suspects like PHP, MySQL, JavaScript, and so on. Now let's get started. We all see it. AI is everywhere. Everyone is using AI for writing, for searching, for coding. But in a business, it's different. You don't just need any answers. You need the right one. And you need accuracy, reliability, speed, and cost efficiency. And there's the challenge. Large language models hallucinate. They make things up. And your data, it changes too fast for its training. And that's the gap between the AI hype and the business reality. And this is exactly where the RAG comes into a picture. So what exactly is a RAG? It stands for Retrieval Augmented Generation, and in simple terms, it combines a large language model with your trusted data source. Instead of guessing, the model retrieves the real information from your data and builds answers on top of it. That means no hallucinations, no made-up facts, just reliable, grounded answers. It also means you get the near real-time responses without the need for constant retraining the model, even when your data changes fast. And the answers can be reliable based on the real data. So at the end of the day, RAG gives you best of both worlds. It combines the large language model intelligence with the truth of your own data. Now let's take a look at the simplified diagram here. And we can see that user input here is used as a search into a data source, which is a RAG. And the data retrieved from the business data source is combined as an input to a large language model. And it is important to understand that the data that we send to large language models is also nothing but a textual representation of the data. At the heart of the RAG, there is one powerful engine called a vector database. And this is where we store the semantic embeddings. Those are the numerical representation of a meaning. They let the machine understand what something means, not just what it says. With that, we can run similarity searches, find metadata that means the same, and it's how we bring the true context to an AI. RAG is context aware, and the vector databases becomes a bridge connecting the structured data with a large language model. It is what makes retrieval augmented generation actually work. And there are so many great examples of vector databases like Quadrant, Milvus, Waviate, Pinecone, even Elasticsearch too, and so much more. They all play the same vital role. They keep the heartbeat of the RAG alive. Here we see a 3D representation of an embedding space. Think of it how AI sees the meaning. Each of the dots here represents a piece of text that's been turned into a vector, a position in multi-dimensional space. The closer the two dots are, more semantically similar their meanings are. So MacBook and laptop end up close together because they describe a similar thing. Tablet is a bit further apart because it's a slightly different concept. And this is exactly how semantic search and a RAG retrieval works. When a user asks about the portable computers, the system finds nearby vectors, which is MacBook, laptop, and notebook, even if the exact words doesn't match. And that's how AI understands the meaning, not just the keywords. So you might be wondering, where does Pimcore fit in all this? Well, it sits right in the center. Pimcore is a data foundation, the single source of truth that feeds everything else. Before we even think about the AI, we need to make sure that our data is clean, consistent, and connected across the channel. And that's exactly what Pimcore does the best. It centralizes a PIM, which is a product information management, data assets management, content management system, and the master data management into one structural accessible ecosystem. When we integrate the RAG and AI model, Pimcore becomes a trusted data layer, the system that provides right information for embeddings, for vector databases, and for contextual retrieval. So whenever you are generating a product description, answering customer queries, or enriching content, AI always relies on verified structured data coming from the Pimcore. Now let's take a look at the big picture here, the architecture that ties it all together. It all starts on the left side with ERP or any upstream system, and that's where the initial data comes from. From there, from ERP, the initial data is then flowed to Pimcore, and this is our central hub, the control center for all the data. Inside of Pimcore, we begin the data ingestion. We prepare, we transform, and manipulate the data that we send to a RAG database. And that's where data becomes semantic, ready for embedding, search, and for retrieval. Now let's move on to consumer side or a customer side, or even the system can be the one that consumes all this. When a user or application sends a query or request, it is flowed to Pimcore. And in Pimcore, we enrich that data and we load the prompts, and we actually send them to a large language model agent. So imagine that you have a web shop and you can enrich the data from the Pimcore custom management segments and send it to a large language model. Then the large language model knows the user preference. It knows what the user have purchased, or maybe what are the segments of that customer is. And once you hand it off to a large language model, those agents actually can reason, plan, and decide which tools to use. They can query the database. They can call other tools if they need. They can also call another large language model agent that can then call other tools as well. The agent can also communicate with the Pimcore, so let's say they might want to grab some data from the Pimcore database to even enrich it more, the context, or get the answers from the MCP server. And the result is then a flow back to a Pimcore where we can store, validate, and further process our output, and finally deliver it back to the consumer in a clean and a meaningful way. So the entire loop from ERP to data ingestion, it all flows through one consistent, intelligent pipeline. And that's the architecture that is connected, modular, and ready for growth. Each of the connection points can be looked as a small architecture for itself, but we will try to dissect in the next couple of minutes. Now let's take a step back a bit and let's be honest. There are so many tools out there, so many AI models, so many embedding models, and every week there's a new vector database, there's a new model that promises to be the one, the best model out there, and so much more. You try one approach and it doesn't work the way you hope. You tweak, you test, you read endless documentation, and before you know it, you lost hours, maybe days, just trying to figure out which tool to even build for. Sounds familiar? Okay, so you finally make a decision. You pick up a few models, you start developing, you put in hours, the planning, the coding, the testing, and by the time you're done, the solution is already outdated. A new model is out, a new database just launched, and suddenly everything feels like one step behind. And that's the pace of an AI today. It's moving faster than our development cycles. And that's exactly why we need to build flexibility and architecture that adapts instead of starting it over. So what's the right philosophy? What's the approach that actually works, not just today, but tomorrow too? It all starts with a simple idea: freedom. And that means no vendor lock-in. You should be free to choose your models, your database, your tools, without being trapped to someone else's ecosystem. Next, fast data ingestion. Your architecture should bring the data in quickly and keep it in sync quickly. Then there is a swappability. You should be able to swap a vector database whenever you need. No write, no pain. And same goes for the models as well. You want to have swappable models. And all of that sits on architecture that's scalable and adaptable, something that grows with the solution as data grows, as business grows, as an AI evolves. This isn't just a stack of technologies. It's architecture for growth, built to move fast and built to last. So how to achieve no vendor locking? It starts with having a strong data foundation. And the good news, you already have that. Whether you are using Symfony, Pimcore, or Laravel, or any other framework, the concept stays the same. It's about the architecture and not a specific tool. Community is big. We have a huge community around those technologies that are open, supportive, and always evolving. The key is to use modular open source tools, so things like LangChain, NAND, LangFlow, Flowwise, and combine them to create exactly what you need. Write one adapter to export your data. Keep it configurable so you can switch the system, the tools, or models whenever you want without heavy coding, no starting from scratch. And through it all, put a strong focus on privacy and security, because flexibility doesn't mean compromises, it means control. And that's how you stay open, agile, and truly independent. So let's talk about our data ingestion strategy. So the key concept is basically that it all starts with the bulk ingestion. We load the data at once, fast and efficient, and that's perfect for initializing or re-indexing a large data sets. So think about when you add a new attribute to your data and you want that attribute to show up in a reg database as well. You want to be able to do a fast bulk indexing. Then comes the second part, keeping it in sync. When something changes, an update or delete, the change should automatically flow to a vector database. No manual steps, no lag. And to make that happen, we basically use the event-driven approach. So instead of constantly checking for changes, we let the system react in a real time. It's faster, it's lighter, and it's more scalable. We also give the flexibility to define what gets ingested. So not everything in your table, in your database, needs to end up in a vector database. You have to decide what's relevant and what isn't. Sometimes we transform the data before sending it. We might need to connect other data from other tables to combine it into one field that is more meaningful, or pull in related information from any other data source that we might need. The goal is to make data as useful as possible without making compromises. And the best part is you write adapter once, just once. After that, you can easily swap to vector database without heavy coding and without rebuilds. And this is how we build a future-proof ingestion pipeline that is fast, flexible, and ready for whatever it's next in an AI. Now let's take a look at this diagram, and we see here Pimcore as a facilitator, where we pretty much have our data, which is a Pimcore, and then we have a configuration where we can transform and manipulate the data and pretty much decide how do we want to output that data. And then we have to have a configurable adapter that can actually connect to our tool of choice. And actually our tool of choice is the adapter or bridge to pretty much connect to any vector database or any embedding model that we need in that case of facilitating the data. We can now zoom into that model and take a look at how embedding process works. So you might be wondering, I have a large data, and how do I ingest that large data? I have, I don't know, PDF, which is a 600 lines of files, of text, or pages or whatever. And this is pretty large for a large language model because it cannot process that much of the data. And with large data sets, it tends to hallucinate as well. So we take the content and split it into smaller chunks because large language models work best when they can focus on manageable pieces of context. And then each chunk goes through an embedding model, and that model converts actually the text into vectors, a list of numbers that actually captures the meanings and not just words. And those vectors are stored then inside a vector database, and that's the AI's memory. Later, when someone asks a question, that query is also turned into vector, and the system searches for the pieces of context of that meaning or that means the same thing. It finds the best matches, sends it to a large language model, and then the model generates grounded, accurate answers based on the real data and not by guessing. So embeddings are the bridge. They connect human language to machine understanding, and they connect business data to an AI reasoning. Now let's take a look at some of the embedding models just to give you a perspective what's up there. So the usual suspects, again, we have the OpenAI, the Gemini, Gina, Cohere, and so much more embedding models on the market. Now, here we are focusing key concept around making the prompts and rules in our system. First, we want to make it quick and easy to define a prompts or rules. And that means that the users or developers shouldn't have to dig into a complex configuration or code. It should be straightforward to set it up and to change it a little bit. So those prompts also need to be easily to maintain and to update. So as we learn more of our use cases, as the site evolves, we want to tweak the wording or adjust the logic. It is important to make those updates less technical headache, and ideally with exposed prompts through an interface, something visual or user-friendly where people can manage them directly. And that helps both technical but also actually non-technical but also technical people like developers to keep everything consistent without diving into code every time. And finally, we want the flexibility to swap models or vector databases easily, or embedding models, whatever that's changing from the large language model provider or another, from one to another, or upgrading to a newer system. The idea that this should require little or no the idea is that should require little or no coding. The system should be designed in a way that makes switching models as seamless as possible. So here's why Pimcore truly shines. It all starts because it sits in the middle. It all starts with pretty much having the right data, and from the Pimcore we connect from upstream like ERP or CRM to downstream channels like the AI models, search engine, and automation tools. And the best part is that Pimcore, it is already the data hub, a simple, powerful interface that makes data flow effortless. You don't need a complex code or heavy integrations. Just configure, connect, and go. So tool of choice to connect the Pimcore to any other system or application, and we can define multiple endpoints for different use cases. We can transform the data visually and decide what you want to share and what you want to keep in a Pimcore. And because it's event driven, the moment something changes, it flows automatically to our reg database. And Pimcore becomes I would say, trusted data layer that is clean, connected, and incredibly easy to use. Now let's take a look at a little deeper into how agentic approach actually works. An agent isn't just a large language model that answers a question. It's a large language model that can plan and act, and what's most importantly, it can act in a loop. So it can define at the end of the cycle what's the next step that it will take. So here's what's happened. The model gets a goal or a query. It looks at its context and it already knows, and it can decide what are the next steps. Maybe it needs to call a tool, fetch some data, run a query, or trigger an action. Those tools are exposed to an MCP, the model context protocol, so the agent can interact safely with the APIs, databases, and the systems. Once it acts, it looks at the results, and the loop continues. The large language model decides, what should I do next? Which tool should I use now? Do I have enough information? And after it reaches the goal, it knows to stop and to return result. And that's the real power of agentic approach. You are giving the model ability to reason dynamically, not just to follow a single prompt. And when we combine that with REG for knowledge and MCP for tools access, we get a system that's context aware, adaptive, and completely modular. New tools, plug them in. New data, it adapts instantly. New goals, it figures out how to get there. This is where AI moves from answering the question to actually getting things done. So what is model context protocol really? Let's make it simple. In the simplest terms, your controller functions or commands in a framework, AI can see it and call them. We call those functions the tools, capabilities that are made available to the model. MCP is an open standard that makes that possible. It connects large language models to tools, data, and the system safely, predictably, and in a structured way. It defines how models communicate the context, not just the raw text. so they can truly understand what they are doing and why. Through an MCP, we give models safe access to APIs or databases to real actions without losing a control or security. And it's extensible. You can add new capabilities anytime without retraining or rebuilding the model. Just plug them in. And that becomes the foundation for our agents. Model that can think, decide, and act, using the tools you expose to your framework. So in short, MCP turns your existing functions into a bridge between your application logic and the intelligence of an AI model or agent. Pimcore is an MCP. Pimcore is built on top of Symfony, which is one of the most trusted enterprise-grade frameworks in PHP. Now, the PHP SDK for what we are doing is still in the development. And there's one exciting part to it. And this is that the Symfony has teamed up with the PHP Foundation and also Anthropic MCP team to launch official MCP SDK for PHP. So basically, in the next couple of months, we should have the MCP PHP SDK ready, and this collaboration is just a big step forward because it brings the world of PHP right into new era of AI integration. So in the meantime, what we can do now, let's talk about how we can bring it all together with fast MCP adapter. We can here use in that meantime a Python implementation of a fast MCP as the bridge, the adapter that connects our AI tools directly to the framework. And here's how it works. We route tools from fast MCP straight into our controller methods. That means every tool, every function becomes instantly available inside a framework. And we can make that beautifully simple. We can use PHP attributes to define which controllers are exposable as a tool to a large language model. We can also define and input parameters as well with PHP attributes that we can read and generate the fast MCP server script based on those attributes that we define. And the fast MCP server, that script that we generate, can actually act as a proxy between the model to our framework. So with a little bit of extra code, we can make our logic to loop through those attributes to find a controller's functions and parameters that are defined and put them in a fast MCP server script and use it as our bridge now between MCP and the framework. So no manual mapping, just a clean automated connection from the Pimcore or Symfony straight into fast MCP. And this is how we bridge the frameworks and AI, which I would say is elegantly, efficiently, and with pretty much zero friction. At the end of the day, this is what really matters. The business value for our clients. The strategy is a value for our clients. So first, no vendor locking. That means long-term savings. You have freedom to switch app, provider, or database anytime. No painful migrations, no subscription traps. Second, faster time to market. And because of the modular setup, you can build and launch AI use cases in days, weeks, but not a month, not a year. Third, it's scalable. As your business grows, your architecture grows with you. So you don't need to rebuild everything. Just add new models and new data types, and you're pretty much good to go. Then there is a cost efficiency. You can experiment with the different models or a vector database easily, safely, and pick what works the best for the clients, for you, for the budget. And finally, we want to have a compliance and trust. We want to limit or reduce the risk. And by keeping the data inside your infrastructure, data leakage finds and protects brand reputations. In the end, clients get real value for their investment. They maximize their data potentials safely, flexibly, and cost-effectively. So let's take a moment to look at what we achieved. We've built something powerful. We connected structured, trusted data with the intelligence of an AI system, and we've done it in a way that's modular, open, and future-proof. We've shown how Pimcore, RAG, and MCP come together to create an ecosystem where data flows seamlessly, where models can reason, act, and adapt. We eliminated the vendor lock-ins, made it easy to swap models in vector database or embedding models, and design an architecture that grows with the business. And most importantly, we turn data into real business value. Faster time to market, lower cost, stronger compliance, and pretty much total flexibility. So this isn't just another AI integration. This is a foundation for the intelligence enterprise system, a system that's ready for what's next. And it all starts with the clean data, open architecture, and smart, connected system. Thank you very much. If you have any questions, feel free to send me an email.